Okay, we're going to talk about how to factor trinomials when there is an initial coefficient or a number greater than 1. In this case, it's not starting with the x squared, it's starting with the 5x squared. Now, the first thing you would always want to do is look for the greatest common factor. Again, let me just show you what I'm talking about. So these are the ones we've been factoring up to this point. There's nothing in front of this x squared. But now we have a 5 there. So we have a number in front. So when I say look for the greatest common factor, is there a number that can go into all of these? Is there a factor that can go into them all? Well, we've done greatest common factoring by doing prime factorizations. This is 5 times 1. This is 3 times 5 times x. This actually would be x times x as well. This would be 5 times 2. So when we look, what do they all have in common is the 5. So the greatest common factor between this trinomial would be a 5. We'll factor it out, and we just divide 5 into each term, and we'd have x squared plus 3x plus 2. And then we can just look at this and factor it like we always do. Some of us like to use the x box. What multiplies the 2 but adds up to 3 would be an x plus 2 times the quantity of an x plus 1. So that's factoring that trinomial, but this 5 that you factored out would just come down. Now this is just a review of the idea of the greatest common factor. But sometimes trinomials don't have a greatest common factor. Let's look at this next example. We have a 4x squared plus 13x plus 3. In this case, if you were to break it down to its prime factorizations, 2 times 2, 13 times 1, there's nothing in common there. 3 times 1, these have nothing in common other than a 1. So you can't really factor anything out. So when that's the case, there is another way to do it. There's actually a couple ways to do it. Now, I've showed some videos already on this, but what I noticed is all the videos show shortcuts, and none of the videos show the traditional way to get the answer. I don't use the traditional way. I'm going to show you a shortcut at the end, but you need to see the traditional way because it really is a great use of algebra and a great review of concepts we've already learned. So the first thing you do is you look at the terms. Now, just as a review, this is called A term, this is called the B term, and this is called the C term. It just goes in order. Okay? And remember, a term is separated by a plus or minus sign. So this 4x squared is the whole first term. So we look at the factors of the A term. What are the factors of 4? Well, it's 1 times 4 is a factor of 4, right? And you could, and then 2 times 2 would be a factor of 4. And another, I'm going to put another 1 and 4 because I know what I'm doing. Okay. Now, what are the factors of 3? Well, it'd be 1 times 3. 3 times 1. That's why I wrote the 1 and the 4 down twice, because I'm having to make sure every possible combination is tried. And then a 1 times 3 also. That's factors of the C term. So all the factors of the A term are here. All the factors of the C term are here. And then what would be the answer if we were to multiply these? So if we were to multiply an x plus 1 times an x plus 4. In this case, if we were to multiply an x plus I'm sorry, I did that wrong. X plus 1 and a 4x plus 3 would be 4x plus 3. This would be an x plus 3 and a 4x plus 1. And this would, and all we're doing is taking the x plus 1 and the 4x plus 3, the x plus 3, the 4x plus 1. You see how the 1 and the 1 are matching? The 4 and then the 3 and the 1. So this would be 2x plus 1. This would be a 2x plus 3. And so you would multiply that whole thing out to see what we would get, okay? X times, but we always know that x times 4x is going to be 4x squared. X times 3 will be 3x. 1 times 4x will be 4x. And 1 times 3 would be 3. Instead of writing the whole thing out, though, we can just really look at the middle terms, okay? I'll write the whole thing out this time. X times x, or 4x is 4x squared. X times 3 would be 3x. 1 times 4x would be 4x. 1 times 3 would be 3. And if you look at the two middle terms, 4x plus 3x, you end up with a 7x. Okay? Good. All right. Now let's try the next one. So x times 4x is 4x squared. I'm not going to worry about that. I'm just going to worry about the middle terms. X times 1 is 1x. 3 times 4 is 12x. 3 times 1 would be 3, but we're just looking at the middle terms. Okay, same thing. We can ignore the first one, but let's do the second one. 2 times 3 is 6x. 1 times 2 is 2x. If we were to add up those middle terms, we'd have a 7x, a 13x, and an 8x. Well, looking at the original question, 13x is the middle term. So we know that the middle term has to be 13x, meaning the right question is this one. So this is the right answer to factoring this. And how do we know? Because we end up with the same middle term. So the right answer would be x plus 3, 4x plus 1. Okay, that is complicated. This was an easier one because there was only a few combinations I could try. But some of these larger ones have many possibilities. It's why we tend to stay away from these. Okay, it's why so many people do shortcuts. But you can see the value of practicing the distributive property twice. It's just a lot of algebra used in there. But let me do another example. Okay, so what if you had one where the C term is negative? Remember, it's A term, B term, C term. So we still do the same thing. What are the factors of the A term? Well, the factors of 2. What times what would multiply to 2? Okay, so I'm going to say that's just 1 and 2, 1 and 2, 1 and 2, 1 times 2, 1 times 2. I've already looked at this problem. That's how come I know how many boxes to make. Actually, I think I put an extra box in. What are the factors of a negative 7? Let's see how the 7 is negative. So you have to do a negative now. 1 negative 7, 7 negative 1, negative 1 and 7, and negative 7 and 1. So those are all the possible ways that you could end up with a negative 7 and switching the order. So again, what are the possible factorizations? It would be 1x. It's a positive, so plus 1. See how I'm just taking this 1 here and putting it here, this 1 here and putting it here, times 2x minus 7. Okay. Same thing here. We'd have 1x plus 7 times 2x minus 1. And we just keep going with it, right? 1x minus 1, 2x plus 7, and then x minus 7, 2x plus 1. And we just find the middle terms between it. So x times 2x is 2x squared, but that's not a middle term. So x times a negative 7 would be a negative 7x. And then 1 times 2x would be 2x. If you add those together, you would get a negative 5x. Actually, looks like we got it the first time. I'm not going to do all these. So this is definitely a complicated way to do these problems. It's long. If you don't memorize this way, it's okay, because it's challenging. I'm going to show you in the next video the way that I actually solve these same exact problems, but without going through all these steps. So to be clear, you don't have to memorize this way. I wanted you to see it. I wanted you to be exposed to it. It's traditionally the way it's taught. I'm going to show you a shortcut in the next video.